when we have a set sit inside another set, we are going to call that a subset. So when we have a vector space and that vector space lives inside another vector space, so this guy lives inside another vector space, we are going to call that a subspace. So basically, W is a subspace of V if W itself is a vector space and it sits inside another vector space V here. For example, if we have R cubed, well, this R cubed itself is a vector space and it is a subset of R cubed because every set is a subset of itself. So we can say that R cubed, this is a subspace of R cubed. And we also have seen from the previous two examples that the span of these two vectors is a vector space, and if I have a solution to the equation x plus 2y plus 3c equal to 0, this is a homogeneous equation, so it is going to be a vector space, and because this guy has 3 coordinates, so they are a subset of R cubed, and the same with the last one, because I have 3 unknown variables here, so I'm going to have 3 coordinates, so they are a subset of R cubed. So what that means is these two guys, they are a subspace of R cubed. And for the last one, if I have the xy plane, so I'm gonna have the xy plane in the 3 dimension here. So this is my x, this is my y, and this is my z. This is my x, my y, and my z axis. So the xy plane is going to be the flat orange plane that we have here. And as you can see, this orange plane, this is a vector space and it sits inside R cubed. So this guy is technically a subspace of R cubed. Or I can actually also view this xy plane as a span as well. I can think of this as a span of the two vectors 1, 0, 0 and 0, 1, 0. So these two green vectors is going to be the vectors in the x-axis and the vector in the y-axis. So these two green vectors here, they would span the orange plane, the xy plane that I have. Or alternatively, I can also view this xy plane as a solution, as a set of solutions to a homogeneous equation as well, and the equation is just gonna be c equal to 0, or I can actually just write this as 0x plus 0y plus 1c equal to 0, or it is just going to be c equal to 0. Notice that if I want to write the solution to this equation, then my x can be anything, my y can be anything, but my z is forced to be 0. And that's basically what I have here. My x and my y can be anything, but my z has to be 0. So technically, I can view this subspace, the orange plane, as a span of some two vectors, or I can think of it as a solution to a homogeneous equation here as well.